on the acid functional group. Okay, so in sodium salicylate, that looks like this. Okay, so the salicylate has given up a proton, and then here's the sodium ion. So are the same chemical forces responsible for the solubility of salicylic acid and sodium salicylate? What type of compound is salicylic acid? This is an ionic compound? It is a covalent compound. What type of compound is sodium salicylate? Yeah, there's an ion, there's a metal in there, so this is an ionic compound. So, are the same chemical forces responsible for the solubility of each compound in water? So, what chemical force is responsible for the solubility of salicylic acid in water? You told me right at the beginning of class today.
That's energy and hydration.
So this is going to be the the intermolecular forces. So it's either going to be London forces, dipole force, or hydrogen bonds. What about this compound?
Lattice energy.
Yeah, this is going to be lattice energy versus hydration energy. So lattice and hydration energy. So would you agree or disagree with that statement? Yes, you want to disagree with that statement because the part you want to disagree with is where it says the same chemical forces. And note that there's different chemical forces involved in the solubility of those two compounds. Okay, so this question 2 is on wintergreen. So let's see, for this one here.
Do number 4.
We're going to do number 4? So number 4 says, according to the label of Prestone antifreeze, the boiling point of a 50-50 ethylene glycol mixture is 265 degrees. Calculate the boiling point of this solution using water dissolvent, then calculate the BP using ethylene glycol solvent. So how do you start this problem? Okay, so to start that problem, what formula are you going to use? Equals times. Okay, so if H2O is the solvent, if H2O is a solvent, what information do we know so we can use this equation? Yeah, so that means that Kb for water, that's equal to, that's from table 13.2, Kb for water is, what was it? 0.52. And let's see, do we know anything else? Do you know what the I value is? Okay, so if H2O is a solvent, what's the solute? So the solute is going to be the ethylene glycol. Now we used to do it in antifreeze lab in Chem1B. We don't do that anymore. But anyway, the chemical form of ethylene glycol is C2H6O2. So, can we figure out the I value of ethylene glycol? Okay, why is it 1? Yeah, that's molecular compound, so I equals 1. What's going to be M Yeah, so the molality, which is M is equal to the moles of solute per kilogram of solvent. So can we calculate the molality of the solution? Because we're given, it's a 50-50 ethylene glycol water mixture.
Is it 50-50 by mass or by volume?
Assume one or the other. Yeah, so it doesn't, for this calculation it doesn't matter, it's usually one or the other. Yeah, so if you want to say it's 50-50 by mass, that means you could say that okay, so if you have a 50-50 ethylene glycol water mixture by mass, that means you have 50 grams of ethylene glycol and in 100 grams of solution, or we're going to take 50 grams of water. So you can do this, or you can say if you don't like using 50, you got 5 grams of ethylene glycol and 5 grams of water. Or if you don't like those numbers, you can say you have 10 of each. It doesn't matter what you use, does it? No, you can use whatever numbers you want. Because the concentration, no matter what, the volume of the solution can be the same. Okay, so if you want to use 50 grams of ethylene glycol, how do you convert it to moles? Okay, so this is going to be our solute. We convert to moles. This is our solvent. We have to use this in the denominator of our equation. So now we know the moles of solute, the ethylene glycol, and the kilograms of solvent, and we can figure out molality, and then we can plug it into this equation, figure out delta T. Okay. If ethylene glycol is a solvent, how is this calculation different? Okay, so ethylene glycol is a solvent. You use the same Kb? Nope, you have to look at the Kb for ethylene glycol. And the solute then would be water. What's the I for water? Okay, 1. And now the moles of water is going to be the same or different? Really? So are you saying that 50 grams of ethylene glycol and 50 grams of water has the same number of moles? No, it's going to be different. So, okay. Then based on these two, you can figure out which substance is considered a solvent. Now it turns out here that ethylene glycol has a boiling point about 190 degrees Celsius. Note that this boiling point here is 129 degrees. So based on our colligative property of boiling point elevation, the boiling point of the solution should be greater than the boiling point of the solvent. So note that this temperature here is greater than the boiling point of the water as a solvent. It's less than the boiling point of the ethylene glycol as a solvent. Therefore, the substance which must be considered the solvent is the water. Okay, based on that boiling point elevation principle. Okay, so we're running out of time here. So anyway, try to find the questions from these old exams which are related to the topics that we covered. And let me also say that there could be some questions related to the labs that we did on the first exam. Okay, so see you guys in the lab. Later.